In this video, we are going to continue our lecture on the Bohr's model. From the last lecture, what we have learned about the Bohr's model is, here's the summary. Electrons travel in a circular path surrounding the nucleus. Number 2, electrons' energy is quantized. Number 3, electrons' momentum is quantized. Number 4, there are only allowable radius for the electron to travel. So these are the conclusion of the Bohr's model. Okay, so today we are going to do some exercise. Let's look at number 2 over here. It says energy of an electron is quantized. And we have seen the formula up here before. And that is equal to energy is equal to negative K times Z squared, where Z is the atomic number. N is the quantized number, or the quantum number, where N can be 1, 2, 3, and on. Okay, let's do some exercise. For example, if I have hydrogen, okay, so for hydrogen, the atomic number Z is equal to 1. I would like to know what will be the energy that is released coming from N equal to 3, that is the excited state, coming back to N equal to 1. I want to know what the delta E is. All right, let's do the calculation. So energy of the Bohr model, it says energy equal to negative K times Z, well, Z squared, where Z is 1 in this case, and divided by N squared. Okay, so let's try some numbers. It says from N equal to 3. So when N equal to 3, what is the energy equal to? Energy will be equal to negative. K is the constant. That is 2.18 times 10 to the negative 18 joules. Okay, and divided by N squared. Okay, we say N is equal to 3. So N squared will be 3 squared, and that would be 9. So let's try. So it will be negative 2.18 times 10 raised to the negative 18 power divided by 9. So what I get over here, it is negative 2.42 times 10 to the negative 19 joule. Okay, so what is the energy on the first level? N equal to 1. It will be equal to negative 2.18 times 10 to the negative 18 joules, and I divide it by 1 square. So what I would get is, it is negative 2.18 times 10 to the negative 18 joule. Okay, because this 1 square is 1. Okay, so delta E will be equal to, coming from N equal to 3. Okay, so that will be when N equal to 3 minus energy when N equal to 1, and that will be this number over here minus this number. When you enter your calculator, be very careful not to make mistakes. Okay, so I will have that number minus negative 2.18 times 10 raised to the negative 18th power. Okay, so from my calculator, it shows 1.94 times 10 to the negative 18. That many joules. Now, let's see what this energy is equivalent to what type of wavelength. Let's see if it is in the visible area, infrared, UV, or in any region. Okay, so what we need to know is, how can we convert this energy into wavelength? Okay, so the goal is to find out what is the wavelength corresponding to this energy. Okay, before we have seen energy of a photon will be equal to a Planck constant times frequency. And we have also seen that velocity divided by lambda, that is equal to frequency. Or in other words, frequency times wavelength will be equal to velocity. In this case, we are going to replace the frequency by speed divided by wavelength. So this one is equivalent to Planck constant times speed of light divided by wavelength. Okay, well, you can copy down this formula because you may need to use it for your assignment or for your quiz. All right, so now how do we isolate lambda? So lambda will be equal to h, Planck constant, times c, and then divided by delta E, the energy. Let's put in all the numbers. H is the Planck constant. It is 6.626 times 10 to the negative 34 power. The unit is joule second. Okay, C over here is the speed of light. So speed of light is equal to 3.00 times 10 to the 8th power meters per second. Okay, and energy is over here. That's the one we have calculated. That is equal to 1.94 times 10 to the negative 18 joule. Let's look at the units. The second over here, it can be cancelled out. The joule over here, it can be cancelled out. So the unit would be meters. That's expected because wavelength is the length. So it should be in meters. All right. So we put into our calculator. I put that into my calculator. And what I find out is equal to 1.02 times 10 to the minus 7 meter. Okay. I'm more familiar with nanometer as for the wavelength. So I'm going to convert this to nanometer. So what I need to do is this one and multiply by 10 to the 9th. So that is roughly equal to 100 nanometer. Okay. So before, what I said was the visible region. So visible light will be from 400 nanometer nm to 700 nanometer. So we cannot see this specific spectrum because it's outside of the range. And if it's UV, that is from 200 nm to 400 nm. So it's not in the UV region. Actually, it's in the X-ray region. Okay. So we cannot see it by our eyes with this spectrum. Okay, now let's work on some exercise. Okay, let's look at number 4 over here. Of the following transition in the Bohr's hydrogen atom. Okay, which transition results in the emission of the lowest energy photon? Okay, so the question asked, the first thing is emission. That means it must from an excited state and fall back to the ground state. Let's look at this one. From n equal to 1 to n equal to 6, it will not emit anything because it needs to absorb the energy to go there. So this one, there's no emission. From 6 to 1, yes, there's something. From 6 to 3, yes, there is something. From 3 to 6, no emission. From 1 to 4, Okay, so from which one will give a higher energy? So ground state is here. Let's say n equal to 1 over here. N equal to 2 is over here. 3, 4, 5. 1, 2, 3. 4, 5. Which one can give us a bigger gap? Let's 6 over here. From 6 to 1 or from 6 to 3. Of course, from 6 to 1 will give us a bigger energy gap. If you want to quantify it, we can do that. So delta E, that is equal to K times, it's a hydrogen, so the Z is equal to 1. 1 divided by the initial, and initial square minus and final square. So you're comparing from 1 to 6. So 6 will be square root 36, or you want it from 3 to 6. Okay, so 3 is 9 over here. So which one it is bigger? Okay, so it turns out to be this number is bigger, and therefore B is the right answer.